Hello everyone, my name is Dr. Michael Atkin, and welcome to the Technology Leaders Lounge. In this series, we explore emerging technologies, new technologies, and we talk to some of the experts that we have here on our Kansas State University Salina campus. Today, my special guest is Doug Zerr. He is our Director of Composites Education for the university and also a faculty member in our Integrated Studies Department here on the Aerospace and Technology campus. So Doug, welcome to the Technology Leaders Lounge.
Thanks, Mike.
All right. So today it looks like you brought some cool stuff here with us. So what's new in the world of composites and what's happening here on the Salina campus in your world?
Well, we have a lot of really interesting things going on right now. You know, at the end of the semester, all of our students are kind of wrapping up their projects. And so today we have 3D scanners, we have additive manufacturing, and then we have the traditional method of layup. In the UAS world, as it quickly develops, we need to be able to repair things that have an unscheduled disassembly. So the way we like to repair those is basically it's an accident reconstruction, clear to the point where we have to put the aircraft back together. Now it's not flyable at that point, it's with popsicle sticks and hot glue, but we need the original form of the aircraft so we can do the repairs. What I have here are two handheld 3D scanners. Both of these are a little bit older. The ones we have now in the lab are handheld. They're about the size of an ice cream sandwich and have just as good of resolution as these do. But we allow the students to check those out, take them into the field, scan parts, and then bring them back in. For what I call digital manufacturing, basically they don't get to possess the final part, they don't get to possess the original part, they just have a digital twin of it. And so from that digital twin, from a good high-end scan, we can then put it through Fusion or through SolidWorks and actually make a 3D rendering of it. Then we can do a lot of things with it. In the case of like this coaster, if you wanted to remake this coaster, we could scan it, make a 3D image of it. We could either 3D print what we call a pattern, which we'd lay up right on, or we could 3D print the mold as well. So it's really streamlined our manufacturing processes. But in the case of the drones, we can then 3D print the parts and the repair that we need to get the drone put back together. And we can actually use the 3D model to cut a new tool. So then basically we either use MDF or some tooling board and use a CNC to cut the shape that we need. We lay new material, which this is carbon fiber. We lay new material into the mold, rebuild the part, put it back on the aircraft, and then return it to service. So it's kind of a quick turnaround of manufacturing, but it's a way of manufacturing that we can do this remotely. Mm-hmm. I have students that are doing this in other towns. They are sending us the files. We are then cutting them here and sending the molds back, so it can be a distance learning thing.
And I'm guessing it's not only just aircraft. I mean, this could really be used in a lot of different applications.
Sure, race car stuff, whether it flies, whether it drives, whether it sinks, whether it floats, it's all about the same composite. So anywhere in the world that this was needed, they can scan it. They can send us the file, we can cut it. So basically it kind of opens up the entire world to manufacturing versus location manufacturing as it currently is.
Some of the stuff I find kind of fascinating is, where we're moving with the technology and how it's combining on this campus anyway. So in my area of computer systems and cyber design, our students are working with 3D models and it's kind of cool that like a computer student could work with a composite student on developing a 3D twin, a digital twin of a part. So to me, that's kind of fascinating. Where do you kind of see this technology going, and what's going to be the biggest impact on industry within the next few years?
So, for the immediate need, it's there are a lot of things to repair nowadays, and so this is a great this is a great strategy in repair, UAS, aviation maintenance, even go fast boats or yachts, anywhere that they're at. We can do this type of repair. You brought up the digital twins. How, for me, it's always exciting to know that we have all the technology capable of building anything that we've ever seen in a video game. So like, cosplay, or we can 3D scan the actual person so that we know once we've manufactured everything that it's exactly going to fit. So it kind of opens up the world to outside of, I want to say, kind of traditional engineering, to where we can build the Warthog from Halo and never actually have a physical Warthog until the end. We can take somebody's character, somebody's rendering from your classes, and then basically build their dreams in reality. I think that's really, really important. And the technology price points have gotten low enough that I have an app on my phone that I can basically do everything that these two can do with my phone in kind of lower resolution. But we have we 3D scanned a 2018 Camaro SS, the entire car, in about 15 minutes.
Wow.
So that all the parts that we made for the car absolutely fit before we never test fit anything. We didn't have to, because it was all generated with the scanners. So pretty exciting stuff, very attainable. That's probably the biggest takeaway here, is it's no longer unobtainium. You can own these.
Yeah. Well, that's really cool. Well, thanks, Doug, for spending some time with us and talking to us about composites. That's all we got for today's episode. We'll be exploring more areas in the future episodes. So until then, we'll catch you later. Bye.